found this crazy old book on group theory and the application of quantum mechanics and atomic spectra. So this is kind of cool. This apparently has some really intense math. So let's just go through, see what they got in the contents here. Vectors, matrices, perturbation theory, abstract group theory, factoring groups, representations, rotations, symmetries. Wow. Okay. Yeah, basically all this stuff. Atomic structure, electron spins, and then yeah. So, you know, time inversions. Okay. So let's see. Basically, it's a whole bunch of algebra, but like this is like super advanced algebra in a way. Like algebra is actually probably the hardest math, you know. Maybe geometry a little bit. It depends what you're kind of doing with it. But you can see how this is just like some very abstract, like what the hell is even happening here? Abstract group theory. Okay, so I think we're trying to like group certain things, and we can sort of like label them with particular coefficients or something, and then we can rotate them around. That's kind of what group theory is all about, is how you can like switch things around and keep the group to be like the same type of group. Yeah, basically each type of group has its own kind of rules, and you know, if you want to switch things around, you have to have very particular rules. So that's what these equations tell you, how to rotate things. This particular rotation is more like has some square roots, whereas this particular rotation doesn't. So here's another type of rotation we can use. We can sort of split apart this and make it into double rotation without, yeah, wow, that's interesting. So yeah, basically I don't really understand any of this stuff. I mean, this is like some sum. This is like really weird, complicated. There's a whole bunch of different like square roots over here. Oh, this is like spins, like spin vectors and stuff. No. Oh my god. Irreducible tensors. I don't even know. This is some kind of an operator here. Oh, the angular momentum. Jesus, this is so cryptic. Look at all this stuff. I mean, what's going on over here? We have like thetas appearing everywhere, sums. Man, this math is so weird. It doesn't even make any sense at all. God, what year was this book written in? I mean, this is what group theory is. I mean, it looks really nice. Spin-free tensor operators. Wow, I don't even... God, this is so weird. So the L and the S and the J are different, like, quantum numbers. So we're trying to, like, rotate quantum numbers around, maybe? That could be a thing that we're doing. If that were the case, then we'd be choosing different quantum states, pointing quantum vectors in different directions and different dimensions. It's kind of what Hilbert space does. Rotations for the operators. So maybe these particles, they're like groups that are switching back and forth according to these rules. What year was this written in, actually? Jesus, this is intense, man. What a cool book. What if we started from the beginning and just really tried to figure it all out from here? That would be so intense, man. 1959. Jeez. Okay. Well, yeah, so this is group theory, kind of. Super hard to understand. Everything in here is just cryptic, like, completely, who knows what the heck they're even doing. But this is the mathematics of the Standard Model. I do believe that you need to know group theory to really get what particles are doing. Anyway, this is kind of a cool book.